we said that computers are made of switches like transistors, and because these switches only have two states, so they only, which by convention we have said that one of them is 1 and the other is considered to be 0. So computers could only understand zeros and ones, and if a programmer wants to tell the computer what to do, he has to tell it using these zeros and ones, which is called the machine language. But using zeros and ones to tell the computer what to do was a bit hard, so there was a need for a more human readable form of talking to computers. Therefore, another language called assembly was created. In the assembly language, each instruction in the binary in zeros and ones would be equivalent to one expression like this. For example, 10001100 would be something like move data from somewhere to other places, or 11000101 in binary would be equivalent to call a function or something like that. So in this case, programmers could use a more English-like expressions to write functions or even read them. For example, if a programmer has written some instructions to the computer, other programmers could easily understand what he meant. But we said computers could only understand zeros and ones, so there was a need for a program that could convert this assembly language to the machine language. This program was called the assembler. So the assembler would get the assembly language as its input, which was written by the programmers, which was a more easier way of talking to of writing programs, and would convert it to the machine language that the computer could understand. But still, this was a bit hard. For example, let's say that with the growing of the processors, that they could just execute longer programs, and there was, for example, an application which was consisted of about 100,000 different instructions. Writing that even in the assembly, or even reading that in the assembly, was so hard. Therefore, there was a need for a higher level language. So let's say, for example, the C language was created. In this case, a code in the C language was equivalent to maybe 10, 100, or 1,000 different instructions. So between the assembly language and the binary language, there was a one-to-one mapping. What we mean is that if there was an instruction in the assembly, that instruction was equivalent to one instruction in the binary. But using the C programming language, one instruction may be equivalent to 100 or more instructions in the assembly or machine language. So different instructions would be packed somehow, that with one line of code we had the opportunity to execute different instructions. And then maybe after that, other higher level programming languages were created that they could pack more instructions. But again, like C, we said when the C was created, because it had to again be translated to the machine language, so a program was created. We call that program compiler. The compiler would translate the C code to the assembly, and the assembler would translate that assembly language to the zeros and ones or machine language. As I said, other higher level programming languages may have been created, and those languages again, they need to be converted maybe to C code, maybe to assembly code, and then from there the assembler would convert it to the zeros and ones. So what we mean is that every code in here, every programming language that was created was to facilitate the programmer's work, and every one of these programs that were created that are sitting in between are nothing but a translator. So compiler is a translator that translates the programming language, the higher level programming languages, to the assembly. Assembler is nothing but a program which again translates the assembly language to the machine language. all of these inventions with the purpose of facilitating the programmer's work was with a cost. The cost was speed or less control, because remember we said that one line of code in C programming language may be consisted of 100 different instructions in the assembly. What it means is that we don't have control over those 100 instructions lied beneath this line of code in C. But in assembly we have complete control over each line, or in machine language we have complete control over each instruction. Another thing that we said was speed, because remember a program in the assembly just needs to be assembled using the assembler to be converted to the machine language, but a program in C or more higher level languages, they need to be translated or compiled to assembly, and then from there they go as input to the assembler, which would be translated to the machine code. Again, as a summary, programming languages are a way to talk to the computers. Computer only understands one programming language, and that's the machine language, which was hard for programmers to talk to computer and create programs. So higher level programming languages were created. The first one was the assembly, which had a one-to-one mapping with the machine language. After that, C programming languages and other programming languages were created. For other programming languages to be understood by the computer, there had to be a program which could translate those kind of programs to the machine level. The program which converts the assembly to the machine language is called assembler, and that who converts the higher level programming languages to the assembly is called compiler.